For our processing project, we took a close look at processes used at Applied Plastics Technology, located right here in Worcester, Massachusetts. Throughout our tour of the factory, we were introduced to many of the different processes they use on a daily basis. We chose to focus on plastic injection molding, specifically the equipment required for the process, the steps of the process, and its final products. In the left figure, you can see a typical mold used by Applied Plastics Technology. On the left face of the mold, there are several holes which are used as cooling channels. The cooling channels allow the molten plastic inside the mold to cool quickly. In the right figure, the process is outlined in detail. The material is injected into the mold, where it is then cooled and solidified to form the desired shape. This particular figure demonstrates the molding of a simple plastic water bottle to demonstrate the basic process of injection molding. The mold seen on the left is a bit more complex. It is composed of multiple parts, which together form a mold used to create windshields for jet skis. Despite the different products, the two molds demonstrate the same injection process.
We make deck plates for boats. That particular mold, the 1006, that makes lenses for jet skis. The instrument cluster. We do compass parts, there's instrument cluster parts, and a couple of medical ones that we do. So we have a pretty wide variety of parts.
Plastic pellets from the feed hopper are siphoned into the injection unit, where they are melted into a homogeneous plastic. The plastic is then injected into the mold through the injection channels. The process in this particular case was driven by hydraulics, which must be constantly cycling when the machine is in use, due to its inability to efficiently turn on and off while the process is ongoing. Once the molten plastic is injected into the mold, it is cooled by water flowing through the cooling channels. The clamping unit that applied the pressure in order to compress the plastic in the mold is then released. Finally, the product formed is ejected and collected for packaging or further processing.
The guy designed a tool, alright? So I'm the guy who has to make the plastic part come out of it, alright? The machine is designed to be able to shoot any type of plastic possible to be done. Now, what I do is I have to set up a parameter of all different angles of what I have to put in here for plastic, for shot, for size, for speed, stuff like that. A lot of the time it comes out of your head from experience, you know. If you build a new tool and I have to go out and process it, I'll get the information from Randy on the material and what I'm supposed to use for it. But basically it all takes time and skill and knowledge from many years of doing it, the experience. Experience is the key to this business. Anything, you know what I mean? So right now I'm going to make this little red plaque over here. So, I notice it's not a big shot, so it's not going to be a big giant shot size. I don't need a lot of speed to get in there, so I don't need a lot of pressure to get there. So what I'm going to do is basically start off like a 29mm shot size. And then if it's too much, I'll cut it back. If it's too small, I'll just keep adding a little bit, but apparently fill it all up. So, we've already ran plaques over here already before, so. Right now we're running an ABS material. My barrel temperatures are up in the 400 degrees. ABS can be melted anywhere between 390 all the way up to 500 degrees, depending on what type of ABS you're using. Now we run this stuff called X11, and I run that stuff up to almost 540 degrees because we make parts for Ritchie. They use big compasses on boats, and everything they want on them has to be nice and shiny. They can't have one little. So, so basically, what I'm doing is I'm setting it up to try to achieve a good cycle on it, so we can make some money. And I'll be able to find out right away, now this is hot. I wouldn't recommend you guys do that. My hands are numb from doing it for many years. Just touch it. Most common people wouldn't be able to hold that in the hand. Right now I'm bringing the carriage in. The clamp should be already set because the person who sets the mold up usually has everything set for me to come over here. The water, everything should be set up. Alright, this injector right there. So I'm looking at my shot right now. Over 10 millimeter cushion on, so I cut this stuff back. Now hopefully that shim behind there is going to hold that so we can blow it back.
This is a kind of old mold, so...
Old mold. Heavy engraving in that place.
Probably just some dirt and stuff like that comes out.
The final product of the plastic injection molding that we observed was a carbon monoxide warning sign used in boats. After ejection, the plastic signs are trimmed and run through a hot stamping machine, which coats the letters of the warning sign in white before it is packaged.
The boats that go on the bottom of deck, on the decks of boats. And then we have different sizes. We do 4, 5, 6, and 8 inch sizes. This particular one unscrews. Both parts are made at the same time in the mold. They come out, put this gasket in, and then assemble them together. Put them in a bag and put them in the box and ship them out that way. These are window frames for boats as well. You got one like this, where after the part comes out, you can see we drill holes in the side as a secondary operation. That's for hinges and things like that, so the window can actually flip open once it's all assembled. And then this top cover is ultrasonically welded onto this piece, and you can see how I have the beads here on this part. So once you apply pressure to it, the vibration will actually melt that plastic and seal each of these channels. Because one of them has air going through it and the other one has the liquid going through, so it draws the liquid out. When it gets down at the end here, it creates a mist to spray it. But another interesting one, we built a couple of molds for a company that strips fiber optic cables. And in this case, all these pieces, you got this piece, and you get two little covers here. They're all molded at the same time. And they just fit together. There's 2 cuts you have to do on this particular cable in order to get the glass fiber out. You strip 2 sides and you kind of strip a 3rd side, and that allows you to get the cable out. These inserts here are ultrasonically welded in as well. The part we were looking at back there, we ultrasonically weld the inserts in. All you have to do, load the part in, place the insert, just push the button. Now your insert is welded in. This is the one that he was talking about.
Like a little like post stick.
Wait, there's a camera that goes in there.
Very
so
cool.
It'll have a cord that attaches to it. In fact, I can kind of show you more what a finished one looks like. Molding this part, you have to have, there's a big piece that's going to pull out of here. in order to form the inside. You got other pieces over here that have to slide out to form these. And you got another one in the back to form the holes back there. So the mold gets to be pretty complex.
Here are a few suggestions that we have made after seeing how Applied Plastics technology operates. The plant would benefit from calculated specifications with respect to the plastic material that is being injected. This would help to avoid excess waste of materials and be more time efficient, as it would eliminate the period of time normally spent adjusting the machine through trial and error. Instituting a climate-controlled atmosphere would also be beneficial to the factory's efficiency. It would allow the process to be streamlined, and employees would no longer have to adjust to seasonal temperature changes, which is often a problem. Under current conditions, without air conditioning and little ventilation, the factory reaches temperatures upwards of 120 degrees in certain areas, which can often take a toll on the company's employees. Climate control would allow for more comfortable working conditions and even help prevent machines from overheating. Another suggestion we can offer to Applied Plastics technology is that they switch to having more electric-powered machinery. Comparative to the current hydraulic machines used, they have a lower cost of manufacturing, run at a higher rate, and ironically, are more electrically efficient. This is because they can pause between generations of each product, whereas the hydraulic machine must be constantly pumping without break. When producing materials in bulk, as is often the case, electric machinery would make for a much more energy efficient process.